This is one of a series of lectures given by the Further Mathematics Support Programme for A-Level Maths Revision. In this lecture we're going to be looking at the Edexcel Decision Maths 1 specification, and the topic is Dijkstra's algorithm. The specification simply says that you should know Dijkstra's algorithm for finding the shortest path. The algorithm takes a look at the path from the start node S of a network through the network, trying to find the path of shortest weight till we get to the final node T, and then we can use the working values that we found to work out which path through that network is in fact the one which has got least weight. Shouldn't really talk about shortest because the weight of the arcs could be they could be distance, they could be time, they could be costs. Really we should talk about the path of least weight. However, for convenience we tend to talk about distance. The algorithm is instantly recognizable, at least the questions involving the algorithm recognizable, because the network will have boxes as shown on the diagram to the left. The parts of the boxes show what are called the temporary working values. This is the shortest distance from S to that point that we found at the moment, and that temporary value may change as we go through the algorithm. At some point we'll find that we've got a final value to go in. That will be the shortest path that we can find at any particular stage of the algorithm. So that will be the nearest point to our start point S at that time. And then, just so we can keep track of what's going on in the algorithm, we give an order of labeling. So we start at S with a label obviously of 0 and 1, so that the starting point S has obviously got it's the first one to be labelled, and its distance from S is 0. From then onwards, at each stage we look at all nodes that can be reached from the last one that has been labelled with its final value, and we adjust the working values on each of these to show the shortest path so far found. We look at all of those nodes which have got a final value. Sorry, I beg your pardon, I've got a temporary value, and a final value is given to the one which has got the least weight at that point. We then repeat that loop, going from the one which has just been labelled, looking at all those points that can be reached from that point, adjusting the working values, and looking at the smallest of those values for the next one to be labelled. And eventually, as we go through, we will end up at the final point T. The shortest path is then found by tracing backwards through the network from T, and a point I is on the shortest path. Sorry, I beg your pardon, the path from I to J is on the shortest path if the final value at J, let's call that the final value at J, minus the final value at I is equal to the weight of the arc IJ. So for example, if this final value at J happened to be 10, and the final value at I was 7, and the weight here is equal to 3, then this is on our shortest path. Right, hopefully all those ideas will now be illustrated as I go through an exam question. In this question then we've got a network of cycle tracks within some national park, and the numbers here are representing time in minutes to cycle along each track. And the first part of the question simply says use Dijkstra's algorithm to find the quickest route from S to T. State your quickest route and the time that it takes. Having done that, we need to explain how you determined your quickest route from the label diagram, and then there's a supplementary question which is talking about can we get from E to T, and how do we get from E to T with our quickest route. So the diagram which you're given in the answer booklet looks like this. So it shows the network, but we've had the boxes that we need to complete put on the diagram for us. So we start with S, and because its distance from S is 0, then that is obviously going to be the smallest one. Our starting point is labelled 1, 0. We then look at every point that we can reach from S. So that would be A, B and C. So and then mark in the temporary label position, or the working values, the value that we have from S to that point. So these are quite straightforward. 24, 61 for C, and for B 18. We look at all of those which have now got temporary values, so in other words those 3 points, and find the smallest of those. That is obviously 18 at B, so that becomes the next point to be labelled, number 2, and it has a permanent value or final value of 18. The algorithm then says from that point that we've just labelled, look to all points that we can reach from there. So that would be C or E. And adjust the values if necessary. Well, we haven't got a value on E yet, so that's just a case of putting the 18 plus 12, which gives us a working value of 30. And if we look then from B to C, we've got 18 at B plus 42, giving a total of 60. Now that's less than the value that we have at the moment. So we adjust the value downwards, because it's a shorter path, to 60. There's no need to cross out those values. You're simply looking at the smallest one. Crossing out you could do, however, you must make sure that if you do that, that the examiner who's marking it can actually read your work. The next stage is where some students might make an error in that they simply look at the 60 and the 30. But the algorithm says you must look at all of the points which have not yet got a permanent value, a final value. So you must remember to look also at A up here, and in fact that is the one which has got the smallest temporary value, so that's the one which is going to be labelled next. It's the third value, and it's labelled 24. Now we keep going. We've reached A. It's got is the last point to be looked at, so we now go from there and work forward, again adjusting the values where necessary. So from A to C we'd have a total of 24 plus 34, which is 58. And from A to D the total is 66. Looking at all the values which are temporary at the moment without their final value put in, you see that the smallest one is at E, right down at the bottom here, so that will be the fourth point to be labelled, and it will be given a value of 30. This is the point we now go from, working from E back towards C. 30 plus 28 is equal to 58. 30, so beg your pardon, 58, so no adjustment there at the moment. We can go from E to F. That's a total of 41, the 30 plus 11 giving us 41. And from E to H giving a total of 77. So now we're going to look all the way around the diagram again to find the smallest temporary working value, and that's at F. 5, fifth point to be labelled, and its value is 41. Now from F, the points that haven't yet got their final labels are C, D, G and H. So there's quite a few to look at here. So from F, working back towards C, we've got 41 plus 15 is 56. This is quite unusual in this question that in fact we're going to now reduce that by working backwards. There's no directions on these arcs, so that's not a problem. So 41 plus 15 is 56. 41 plus 23 gives us 64 at D. 41 plus 38, 79 at G. And 41 plus 35, 76 at H. The smallest value is at C, so that's the next one to be labelled, and that will be labelled as 56 and the 6th point. From C, there's only one now which hasn't got a permanent label, a final label, that's D, and 56 plus 7 gives us 63. You must check round, however, all the points, but that one's definitely the smallest labelled now, so that's the 7th point to be labelled, value 63. We can now only move forward to G, so 63 plus 12 is 75, and again just checking against H, H is 76 which is bigger, so G is the next point to be labelled with a value of 75, and then we're moving forward to T. 75 plus 14 gives us a value of 89. Again, another point where some students might make an error is to say, oh, finally we've got to T, but we haven't actually got to T quite yet, because what we've got to do is to look at those final values, those temporary values, and the smallest one is at H. So H is the next point to be labelled, and that will have a value of 76. And now 76 plus 11 gives us a value of 87 at T. That's the only one now that hasn't been given its final value, so that is at number 10 and length, weight 87. Okay, now to find the shortest path through the network, we know that the weight is 87, of course, because that's our final value at T. But what we have to do is to work backwards from T and use the idea that the final value at a point minus the final value at the point before, so Fj minus Fi, if that's equal to the weight of the arc from I to J, then Ij is on the path. Then that arc is on the shortest path. So, starting at T, working backwards from the 87, 87 take away 14 is not equal to 75, so G is not on the path. However, we can work to H, 87 take away 11 is 76. So what I tend to do is to just put a little marking along the arc, as you've noticed there, just so that I've got I can trace back once I've finished getting back to S. And as we go, we'll find that then the arc comes back to F. 76 minus 35 is 41, and then 41 minus 11 is 30. 30 minus 12 is 18, so we come along here to B, and then back to S. So there's my path, which goes S, B, E, F, H, and T. And the time for the route is 87 minutes. The explanation for that, which you're asked to give, probably best to say something as I've done here, that an arc is on the shortest path if the final value at j minus the final value at I is equal to the weight ij. Part C of the question asks us to give the shortest route from E to T. Now this is just checking that you realise that if you have a shortest path, then any part of that must be itself a shortest path. So because E is on the path that we found from S to T, then the shortest path from E to T must be what we've already found within that longer path. So the EFHT is the shortest path from E to T. The marking for this then was given as follows. There was a method mark for some evidence that you have an idea of what's going on. So some of the boxes filled in, the temporary values filled in, and generally getting smaller. They would want to check that there's some smaller values at C, D, G, H or T. It doesn't really matter where, as long as you've done something. Then there are 3 accuracy marks given depending on how far through the network you get correctly. So they're looking at all of these boxes. So if you complete the algorithm correctly, the diagram should look exactly as you've got on the screen at the moment. So depending on how accurate it is, 3 marks given for the final diagram. There was then a B mark given for the route. That's not a follow-through mark, so you had to get the correct answer for that. However, if you haven't quite got that value right, but you did for your diagram write down the time of the route, there was another B mark for that, a follow-through mark there. Finally, 2 marks for an explanation of how the shortest route was found, and a single mark for simply writing down, again a B mark, no method involved, for writing down the final answer to the route from E to T. Okay, that's the end of this lecture. However, you can find links to other revision lectures on the Further Maths Support Programme website, which is at www.furthermaths.org.uk.